Hello everybody. We're going to do another problem today. It's going to be the next one, week 2, number 8, diameter of a binary tree. So let's go here. It is number 543. Return the root of a binary tree. Given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of a path between two nodes is represented by the number of edges between them. So here's example 1. It's 1, 2, 3, 4, 5. The root is that, and the output is 3. So why is the output 3? 3 is the length of the path from 4, 1. Okay, so let's just draw this. 1, 2, 3, 4, 5. So 3 is the length of the path from 4 to 2, 2 to 1, 1 to 3. So 4 to 2, 2 to 1, 1 to 3. It's also the path between, go ahead and make this red, between 5 to 2, 2 to 1, 1 to 3. Okay, so you have one node goes here, and I guess if this had a node here, and this had a node here, and here, it would continue on, right? It would continue to go from that 3 to here, or that 3 from there to there. But not that one, because that would be shorter. These would be the two options, and these are the two options here. Okay, so this looks like it could be approached. Well, let's look at the example 2. Example 2 is a root. It's a 1, 2, and then the output is 1. Okay. So this looks like it could be approached in many recursive setups that we have for trees. So let's just remind ourselves, how do we set up the tree recursive skeleton, right? So we have a function here, and let's call this solution. We have another function, we can call it go. It takes some type of node, and I'm going to put a pass here for now, and we're going to call go. If the solution gets a root, we're going to call go on the root, right? So this is setting it up. We typically want to call the recursive function go on the left and the right side, right? So here on this recursive function, maybe there's a base case, but then we typically want to call, so let's say from left is node dot left, right? And then from right, node dot right. And then we have some logic. Go ahead and put a comment there. There's a base case. Some logic that we do with the from left and the from right. And for many problems, it could be different logic. We're not sure which logic it is yet, but there's some logic that we want to do there. And typically, it affects some type of results, function, some type of results array or list or variable that we have, right? So we'll have results here equals something, some type of thing. And then, that logic could potentially update results, and potentially our base case updates results, right? Something to do with results. Okay, so let's walk through what this code does. So I'm going to get rid of these little marks. Let's get rid of this yellow thing. Let's get rid of that. Okay, that's fine. Let's just keep it all to avoid the extra work. Okay, so in this code, the solution is going to be called onRoot, right? And that's what everything is called from. You call it from root. In our recursive function, we're going to call from left, right? We're going to call the recursive function on the left, and we're also going to call it on the right. But the right one will happen later, so we'll call it on the left, right? And this is a depth first search. On this node, we also call it on the left, right? And here, this is the base case. There's nothing else for it to look for, right? And when it's called on the left, then it's called on the right. And here, at this point, we have some decision point, right? Something's being returned from the left, and something's being returned from the right. Okay. So first, let's think about the leaf case. If there's nothing in the left and there's nothing from the right, what do we want returned to this node? Well, what are we looking for? We're looking for the length of the longest path between two nodes, right? So the zero case for this one would just be 0, right? If we're calling the recursive function on none or null, let's just return 0. Okay. So, for itself here, what is the length of 4 to itself? Nothing. But what is the length from 4 to this number 2? Well, from 4 to 2, that's going to be 1. Right, so there's at least 1 here, 4 to 2. And what's the length from 5 to 2? Well, that's also 1. Okay. And the logic that we want here is we want to essentially take the longest path that we have available to us, right? So imagine if this 4 had these nodes, right? And all the way up here, the path is 1, 2, 3, 4, 4 edges, right? Which one would you want to continue? Would you want to continue this 2 to the 5 or 2 to the 4? 2 to the 4 actually has additional edges, right? So at this point, this is the logic point of deciding whether your diameter is going to include the path from your left or your path from your right, right? Like which one has the highest depth being returned to the 2, right? And this is exactly what we have here. I'm going to move this so it's right next to it. This is at from left and from right, right? So from left and from right, it's going to return, I guess I'll make this blue. It's these two returns, right? What's being returned to the 2? What value from the left and what value from the right? And then we can do some logic. And I guess there is another case. Wow. I mean, now that I'm looking at it. So there's 3 cases that would make this viable as a diameter. And I'm going to put this in red. Okay. So in one case, this 2 is your new root, and the diameter is the length of everything from the left plus everything to the right. Right? That's the diameter. That's the longest path. In the example 1, the 1 acts as that. The 1 acts as that pivot, where it's everything to the left plus everything to the right. And, that's okay. So now that I'm looking at it, at any node, when it's a pivot is when that node is potentially, part of the longest diameter as a pivot. If it's not a pivot, then, you still have to decide what to return up to the 2, right? Do we return from the 5, this 1 length, or do we return from this 4 plus these 4 edges, right? Okay, so this is part of the logic, right? So part of the logic is diameter update based on node as the pivot, right? So that node is a pivot, you might want to update the diameter. Now, given that, you still want to return, so I'm going to put a 1 here. You still want to return something. And when you're at this node 2, do you want to return the path from the left or the path from the right, right? So return longest path from left or right, and plus yourself. So these are two things that have to happen at a node. So if I'm calling a function go, right? I'm calling go on any node. Let's say I call it on this 2, right? Then it needs to have at least 2 pieces of logic. It needs to do a diameter update. So say, hey, the diameter could be increased based on this node as a pivot, right? And that's going to be the addition of left and right. Or, and not or, but and, step 2 is going to be returning. So when I, when I called go on 1, it's from left and it's from right are updated. So it might be easier if I just type the code. That way I can hash out the details. I might be missing something here. So diameter of a tree, let's go ahead and make this much smaller. Okay, let's think about what we need, right? We at least need a go function. Go ahead and make that pass. And the go is going to be passed in this root, and we're going to return something, right? And the thing we want to return is diameter, right? And to keep it simple, you could call it result, but it might be a little confusing. So diameter here can start, I guess, with 0. That's your skeleton for the helper function, right? You have some result that you want to return, diameter. You have some definition of a function, and then you call that function. Now, we have a base case, right? Because this can be called with none. And if the node is none, well, then you just want to return 0, right? You want to just get rid of it. Or not get rid of it, but like what's being returned to this 5 right here, you want that from left to be 0 and that from right to be 0, because you don't want it to represent information. Okay, so from left, from right, and from left is simply go node.left. From right is go node.right, right? Okay, so we have some logic here, right? So I'm going to go ahead and say this is the recursion, and this is the logic. And this is a very common skeleton we're going to use with many tree problems. Okay, so what's logic number 1? It is a diameter update with this node as a pivot node. And number 2 is, return either left or right plus, itself plus 1, right? So what does it mean to be a pivot node? Well, what was the length of left plus the length of right, right? So as pivot diameter, you can call it, equals from left plus from right. And, that's here. That's just 2 adding up from the 4 and from the 5. And we can go ahead and update diameter based on that. So diameter equals the maximum of the current diameter, or this current pivot diameter. And then this recursive function needs to return to whatever's called it, right? So it has to decide what to return. And it's either going to be left or it's going to be right. And what you can do is you can say diameter max length from left or right. So we could probably think of a better name for this, but basically you're taking the max from left and you're taking the max from right, right? And I'm going to put this in, running out of colors, maroon here. That's, maroon is a bad color for this. Maybe I'll make it green. So that's here, that's this from, and that's this from, right? And we're trying to think about what is the max. And what we want to return, let's say we're returning to this 1, is all the edges based on this uninterrupted line of nodes, right? So what we want to return is the max length from left or right plus 1. And we might run into an issue where we can't update diameter in Python unless we use non-local. But let's try this and see if we run into that problem. Okay, cannot access local variable diameter where it is not associated with a value. Okay, so I believe we have to do non-local diameter, and that gives us the global scope, or at least the lexical scope, of this solution dot diameter of binary tree. Okay, so this follows a very standard recursive template where we're getting the information from the left, getting the information from the right. We have a base case, and we have some logic that determines updating, right? Updating and outside scope the variable is number 1, and what it's actually doing is this. And then number 2, returning something, right? Returning the unbroken line of node edges from this tree, right? And that's it, right? And then once we get to the root up here, once we get to this 1, it does the final calculation from left from this 2, from right from this 3, and then if something is, a larger diameter, it updates it here, and then it returns. Now the 1 doesn't have to return to anything. That's why when we have here, this go actually has a variable that's not being captured here. We could if we wanted to, but that would be the end of our computation needed. Anyway, thanks a lot for watching. Please follow along and do this yourself. I'd recommend drawing the diagram before jumping into the code, and then when you're ready to do a real practice, open up the code editor. It's not as helpful without drawing. I think when you draw, you can pretty much intuit what you want from information. And if you can't intuit it yet, just zoom in. What information would this 2 want, right, in order to contribute to the conversation? This 2 needs some information from its left child. It needs some information from its right child. And then it can perform some logic, right? And that's it. And what information could this 5 want, right? This 5 has no right child, has no left child. What can it contribute, right? And I think that helps with the recursion for me. because it's the same logic for every one of these nodes, right? It's important to know that we're running the same code for every one of these nodes, whether it has children or not, right? So here, this base case handles that case because we're calling node.left even when the node doesn't have children. So this 5 has this go called on it, has this other go called on it. Those return 0, from left is 0, from right is 0. This pivot has a diameter, also 0. The diameter will not update because it's 0. And then maximum from left to right, it's 0, right? But the 5 still has to contribute this 1 because it contributes the connected edge from the 5 to the 2. Anyway, this was a really great exercise. I hope you try it yourself. Thank you for watching, and I will see you next time.